welcome to another video where today we are going to be discussing bridges and specifically why bridges have been so vulnerable and what can be done about that in the future. So I'm with Stefan, who has decades of experience working with technology and cybersecurity and distributed ledger systems. So we are going to make use of his expertise today.
Hi everyone.
The first thing that I wanted to start off with in terms of bridging is, could you give us a little bit of an overview of how they typically work? I know that there are different mechanisms, but just in more general terms, how do bridges in blockchain typically seem to function?
Yeah, I mean, bridges are really designed to solve this problem of blockchains being silos. You have assets on one blockchain and other assets on another blockchain, and it's very difficult to move these around. And traditionally, people have done that using things like centralized exchanges and indirectly, right? So you sort of sell something for another thing off chain. And bridges try to do this on chain in a way, but obviously there are two ways of doing this. You can do it like in an automated centralized bridge where you have just a single relayer translating transactions from one chain to another, or you can do it in a decentralized way where you have a set of nodes reaching consensus on which transaction should be transferred from one to another. And it's technically not easy to do that. And there are a number of ways of doing this, but in general, there's one thing most bridges have in common, that you sort of lock an asset away on one chain, let the other chain know that you've done that, proving it somehow or by a signature or some other cryptographic way. And then on the other chain, you create a representation of this asset by minting some sort of token. And in the inverse way, you sort of burn this representation of the non-native asset on one chain and free up the locked away asset on the original chain. That's how bridges work in general, and obviously they've become quite popular because there are a lot of different blockchains around now, and they are trying to communicate to each other. And as is always the case, if there are new things, there are new ways of exploiting new things, and we've seen a number of attacks last year.
So speaking of attacks, how would you say the construction of bridges has made them more vulnerable to attacks? Is there anything that stands out compared to other parts of the blockchain ecosystem?
Yeah, I mean, they are more vulnerable in a way that there are a lot of technologies and a lot of moving parts involved. And that opens up a large number of attack vectors. Usually a blockchain is written in a certain language. In the ideal case, you might have several implementations in different languages that implement the actual protocol. but it is one set of rules, one consensus protocol, and all the nodes know what to do. And then there's still a lot of attack vectors and a lot of moving parts, but on top of this, you might have a smart contract, and smart contracts are very reduced. And we've seen a lot of smart contract exploits, but the scope on the number of attack vectors is quite limited because they are just a certain size. They're not that huge usually. But then when we talk about bridges, you have at least two blockchains usually and different technologies. They will have slightly different consensus rules. They will have different ways of what they consider a safe, secure transaction. So there might be a difference of finality. For example, if you have something like Cosmos, you have or Tendermint-based blockchain on one side, you have instant finality, or at least you have a point in time when transactions are considered final; they won't be undone. And if you're bridging to something like Bitcoin, on the other side, you don't have this. You have probabilistic finality. So with each block added to the chain, it's less likely a transaction is undone. So you have a different interpretation of the rules already there, and what is consensus, which is difficult to solve and opens up attack vectors. Usually you have some sort of third consensus technology in the middle that is the actual network of relayers. So you either have a centralized node, a centralized relayer that you have to trust from one blockchain to another. So that's another attack vector. You have someone holding keys to freeze assets on one side and free assets on the other side. So there's things that can go wrong there. Transaction could be replayed there. The actual node could be hacked, someone getting access to the private keys. Or, if it's a decentralized bridge, in the ideal case, you have several nodes, but then you have another consensus protocol implemented in a certain technology to worry about. So there are things that can go wrong there. The actual consensus layer of the bridge can be attacked. And in general, you have smart contracts on one side or something similar, some piece of code that locks away and mints stuff on the other side. You have the cryptographic libraries that are used to do the signatures off-chain, and you have all the peer-to-peer code of the relayer network. So there are a lot of moving parts, which just means there are a lot of places where things can go wrong. That's the main reason bridges are more vulnerable than other pieces of code, or at least than simpler blockchain projects. And even there, we see a lot of hacks, so it's not easy.
So it's the complexity and how many different things a bridge, I suppose, is trying to do in order to have one transaction go through.
Yeah, and there's a complexity and the that's one big thing. And the other big thing is the nature of bridging assets. When you bridge assets from one chain to another, there's a problem that you have these assets existing on both chains, and maybe you have several bridges between two assets, and you have certain assets on many different chains, which means that the asset is diluted, or diluted is maybe not the correct word, but it's fragmented, and this means you have smaller pools in many different places. So that's the economic problem. Protocols are usually easier to attack if pools are small. Then it's easier to manipulate a price if you have a small liquidity pool on some sort of decentralized exchange. So that adds another problem. And there's also something Vitalik Buterin pointed out in one of his posts, that there's a limitation of non-native assets on a blockchain. It's like if I have an asset on a certain chain and I have it on another chain, there are certain protocol rules that should never be violated. Even if a blockchain is attacked, they tend to hold, like, there can't be more ETH than ETH in existence. But if you have ETH on Solana, for example, that rule doesn't necessarily apply anymore. Ethereum doesn't know about the amount of ETH that might be accidentally created through some sort of exploit on another chain. So there's an inherent protocol security issue with dealing with non-native assets. But yeah, there are three things. So the number of places where a bridge can be attacked, the number of, the fragmentation of the assets, and the inherent insecurity of dealing with non-native assets.
So what can founders and developers do? Are there any sort of best practices when it comes to bridging, both from an economic standpoint and from a programming standpoint, whether that's that you want to create a bridge or you're a protocol that knows that you're going to need to rely on bridging? Is there any, best practices that people should look out for?
Well, yeah, there are two things there are a number of things that can be done. And it's not too different from any other piece of critical software programming and financial software. So be, the main part is to put security first and be very conservative. Think about all these moving parts. So have experts for all these moving parts and use very good security practice for all these moving parts. And it's just the way these things should be developed. And then obviously, when you develop bridges, there is a risk analysis that has to be done. It's like if you move very large amount of assets, the risk is larger. So have things like delays, right? So you can do things like if you have a small transaction to be moved from one chain to another, that could be almost instant. But maybe if you move millions around, being instant is not that good. So if something does go wrong, you have a sort of a lock away period to and maybe like a big red button. But then again, you have this trade-off of who presses this button and when to stop things. But at least when you develop things, you can have certain fail safes in mind and obviously be very defensive. And then the second thing you have to do with a bridge is monitor it, right? So there's no point. Well, there's a point, but I mean, it's not a good idea to have a bridge running and just trust it all the time. So if there are strange transactions, you should realize as quickly as possible. There have been exploits where people realized very late that assets were minted that shouldn't have been minted, and there are things that can be stopped earlier. Other than that, it's just best practices in engineering should be applied. If we are not happy to release 1,000 lines of smart contracts very easily without 100% test coverage and without very methodological security approach, we should not do that with a 1 million bridge, 1 million line of code bridge. The timeline and the number of steps involved in security should be taken into account according to the complexity of these things.
And are there any specific hacks or exploits that stand out that are just good kind of case studies for people to look at and learn from? Not to call out names in particular, but just any types of exploits that stand out.
Yeah. I mean, there are some. The best ones for me are the simple ones. Like there were a few exploits where the transactions were detected by an event coming from a smart contract, and there were some exploits where they forgot to filter for the actual source of the event, so they just detected the event type, but the attacker could just write a similar smart contract that emitted the same event and fool the relayer into thinking that there were valid transactions happening. That's funny in a way because it's so simple, but it's not uncommon. So that these are good examples of very simple things that are easily forgotten. And sometimes people do. There was one other case where there were extremely clever cryptographic signature schemes, but they never really verified the signatures. So it's easily done. I mean, the best way to think about learning from what has happened before is to draw the picture of a diagram of a bridge with the two parts, the relayers, and then look at all the exploits that have happened and classify them into where they attacked and which part of the protocol. If it was a signature replay, if it was an event duplication, or if it was just some private key leakage, and you can classify these things and learn from them.
So that's some homework for everybody, is to work out what
Yeah.
happened on the bridge hacks. Is there anything else, Stefan, that you
Yeah,
wanted to
and
add?
they're good. No, I mean obviously the 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 logical step from our point of view as security auditors is to think about which parts of these need a careful look by security experts. Obviously, we would like that to be us, but in general, you should think about people should think about when to get security experts involved, which might even be in the early stages of deciding how you want to build a bridge and how you want to set up the consensus protocols and the operational security of running these relayer nodes and things like this.
I've thought of another question actually that I would like to ask you is, for projects that are wanting to make use of a bridge but not necessarily build the bridge itself, they might have a few different options of which bridge to choose. Is there anything that you would recommend they look out for, like when going shopping for a bridge? Are there any sort of key things that stand out as being good?
Yeah, I mean, obviously, ask the right questions. Look at who's behind these bridges. What's the history? How has the team developed them? Who have they been audited? Which parts have been audited? That's obviously the basic homework. And then the next step is what's the operational security like? If it's a bridge with a relatively low number of nodes and it's like a multi-sig scenario, who are these signatories? How independent are they? What do they have to do to be a signatory? How do they keep their signatures safe? That sort of thing. Um, and then also look at volume, right? Obviously, everyone has to start somewhere, and when a bridge just fires up, it's probably not got the biggest volume. But a bridge that moves a lot of assets and has been running for a while and is generally considered secure by the community will have a less. It'd be an interesting target for an attacker, but on the other side, it will have a less. A lower likelihood of liquidity problems and things like this, and just 0 days exploits that nobody has noticed yet.
Awesome. That is all the questions that I have. So unless there's anything else that you wanted to add about bridging, we can wrap this one up.
No, I think we are good.
All right, awesome. Thank you for watching, everybody. And if you do want to find out more about security, about the audits that we offer, you can check out the links in the description and you'll find all the information about us. So thank you.